Hey guys, welcome to PCMINR.com and you're watching this video on Uniform Motion by Sonal Gupta. In our previous videos, we learned about distance and displacement, and now we are going to learn that how can we say that something is moving slow or fast. So yes, we are going to learn about an important term of mechanics which describes a motion, and that is speed. Speed is a parameter that gives us a lot of information about the motion of an object, like whether it is towards or against the force, or is it uniform or non-uniform motion. Speed measures how fast or slow something moves, and this depends on the distance an object travels and the time taken to travel that distance. So we can say speed can be determined with the general formula: speed is equal to distance upon time. So that is the formula we are going to use to find out the speed of any object that is moving. So let's say you make a car trip that covers 245 kilometers in 5 hours. Then what is the speed of your car? So we would say speed is equal to distance upon time. So that is 245 upon 5. So that gives me 49 kilometers per hour. So this is a simple method how you can determine how fast or slow an object is moving. Now, depending on the units that you choose for the distance traveled and the time taken, you can find the units of speed as, like, if you have the unit of distance is meter and the time is measured in seconds, then obviously the speed, the unit of speed would be distance in meters. So that's meters upon time in seconds. So you get the unit of speed as meter per second, right? So the unit of speed is meter per second, and this is the SI unit of speed. If the unit of distance is kilometer and the time is hours, then the speed would be distance in kilometers upon time in hours. So you say the unit of speed is kilometer per hour. But generally in your numericals, you will have to convert this into meter per second. So you should always have all the quantities, all the parameters in the same set of units. So if you choose kilometers for the distance, then hours should be the time, and then kilometer per hour will be the unit of speed. But if you choose the distance in meters and time should be seconds, and then you have the SI system, so meter per second will be the unit of speed. Now, while moving on the road, you generally don't move at a constant speed. The speed may increase or decrease depending on the speed limits, traffic on the road, traffic lights, and many more factors. For instance, you can travel at 100 kilometers per hour when you're traveling on an expressway. But if you are traveling on a road with a lot of traffic, you see you may not even touch like 40 kilometers per hour. So you have to stop on the traffic lights and in the jams. Therefore, the speed of a vehicle is never constant. So you should know that the speed of a moving vehicle, which is shown by the speedometer of the car, is actually the speed of that vehicle at any instant. So we actually say the speed of the vehicle at a given instant. It is called as instantaneous speed, and the speedometer, it just gives you a average speed, instantaneous speed. It doesn't give you a uniform or a constant speed, because if you look at the speedometer, the speed is changing every second. And since the speed keeps varying every moment, the speed of a car during a journey can be calculated from the average speed of a car, and where we define the average speed as the total distance traveled divided by the total time taken to travel that distance. So I would say average speed is total distance traveled upon total time taken. right? So here it's not just the distance in one side. So if you go and come back, you find the total distance and the total time you take for a complete journey and divide the two. Now, depending on what all is given to you, you can use two different formulae for average speed. Now, first is the case when you have an object, it travels at a speed a, say for a half time t by 2, and speed b for the other half of the time t by 2. Right, so here we have time split into two equal halves, and the speed is a for the first half and speed is b for the second half. So in that case, how do you find the average speed? So first you need to find the total distance traveled. The formula for the distance would be velocity speed into time. So we say a is the speed in the first half, so a into t by 2, right? And plus b is the speed in the second half, so we say b into t by 2, sorry. So you get total distance as AT plus BT by 2. And the total time taken is T by 2 plus T by 2, because it's T by 2 for the first half and T by 2 second half. So that gives us a total time of T. Therefore, the average speed, the formula is total distance traveled upon total time taken. Now, total distance traveled is this, that is AT plus BT by 2 and divided by the total time taken, so it will be T here. Now T throughout is common, it can be cancelled out. So you have A plus B by 2. So this means that if you have speed A for first half and B for the second half, then the average speed is the arithmetic mean of the two speeds. And the second case is when an object travels at speed a for half the distance, for the first half of distance d by 2, and speed b for the other half of the distance, so for the other half of the distance d by 2, the speed is b. Now in this case, the total distance traveled is d by 2 plus d by 2, so that is d. And total time taken can be calculated from distance upon speed for the first half. So d by 2 by a is the time taken in the first half of the distance, and d by 2 upon b is the time taken in the second half of the distance. So therefore, again substituting, average speed is total distance traveled upon total time taken, so it's d upon the time is, so we get d by 2a plus d by 2b from here, and d will be taken out common here, so we get d into 1 upon 2a plus 1 upon 2b, and this d is going to cancel out, and so you get, when you take the LCM, you get 2ab, it goes on the top, upon a plus b. Therefore, we see that if an object travels at a speed a for half the distance and speed b for the other half of the distance, the average speed in that case is the harmonic mean of the two speeds. So if the object travels at speed a for half the time interval and b for the other half of the time interval, the average speed is the arithmetic mean of the two speeds. But if we have the same thing, the speed a for half the distance and speed b for the other half of distance, we have average speed as the harmonic mean of two speeds. Now we move to the next important parameter, and that is velocity. Now the speed can actually just tell us how fast or how slow an object is moving, but it doesn't tell us anything about the direction of the moving object. So when we measure both the speed and the direction, it is called velocity. So velocity, we can say, has a magnitude as well as a direction, where speed has only the magnitude and no direction. So mathematically, we define velocity as speed plus direction, you can say. Or since now we know the difference between distance and displacement, so speed is distance upon time and velocity is displacement upon time, right? So that's the difference between the formula. Whatever difference you find for distance and displacement, same are the differences for speed and velocity. So the formula for velocity is displacement upon time, and the units you will have will be same because it's again the length upon time. So unit for velocity is also meter per second, the standard SI unit, or kilometers per hour. So interestingly, you see here that if two objects, they move with the same speeds but in different directions, then they have different velocities. So as you can see the two cars here, the speed, if you find the magnitude, is 20 kilometers per hour and 20 kilometers per hour, but they are traveling in opposite directions, so they have same speed but different velocities. And similarly, if two objects, they are moving in different directions and also at different speeds, then definitely they will have different velocities. So when speed and direction both are different, obviously the velocities have to be different. Now see, though the formula for calculating average velocity is quite similar to that for average speed, but it should be noted here that average speed can never be zero, but average velocity can be zero depending on the displacement made by the object. So let's look at an example. So let's understand the difference between average speed and average velocity. So consider the motion of a child around a rectangular park. The child walks 6 meters east, then 4 meters south, then 6 meters west, and finally 4 meters up north. So the entire motion lasted for 40 seconds. So what is the average speed of the child? So average speed is the total distance traveled upon total time taken, and total distance traveled here is 20 meters, 6 plus 6 12 and plus 8 20, upon time taken is 40 seconds. So you have 0.5 meter per second. That's the average speed. But what about the average velocity? Since the child returns to his original position, so you all know the displacement is going to be 0, and so the average velocity is displacement 0 upon time 40. So you get 0 meter per second. So average speed cannot be 0 because there is always some distance traveled, but average velocity will be 0. So you should know actually that the speedometer of a car is measuring the speed at any instant and not the velocity, because your speedometer tells nothing about the direction. It just gives you the magnitude of the rate at which the vehicle, your car, is covering a certain distance. So speedometer measures this instantaneous speed and not the velocity. In the next video, we shall continue with the concept of uniform motion and take it to non-uniform motion. If you find this video helpful, please subscribe, like and share, and follow us at PCMINR.com. Thank you.